Hello and welcome to iLearn Review Day 4. Today we're going to look at how to write an equation from words, and then we're going to solve that equation, and then we're going to look at how to solve inequalities, and then also how to graph them on a number line. And we're also going to take a look at determining whether or not something is a function based on a graph. So we should be doing problems 34 through 43 on your worksheet. So let's take a look at number 34. We're going to read this phrase and then we'll see what it says. So it says, Jack is going through the lunch line. He picks up a salad for $2.50, a slice of pizza for X dollars, and a drink for $1.25. He spent a total of $5.50 on his lunch. And it says, number 34 says, Part A, write a linear equation to represent this situation. And so here's how I do this. There's more than one equation that's acceptable for this, but it says he was going through the lunch line and he bought a salad for $2.50. If I add his pizza that he bought for X dollars, and then I add his drink that he bought for $1.25, that is equal to the $5.50 that he spent on his lunch. Now, a lot of people would go ahead and combine like terms here, $2.50 and $1.25, and you would get $3.75 plus X is equal to $5.50, which is a perfectly acceptable equation, but both of them are. So if you left it as $2.50 plus X plus $1.25 plus or equals $5.50, that's a perfectly acceptable equation. Or if your final equation was $3.75 plus X equals $5.50, that would work as well. Number 35 says to solve the equation you created in Part A to determine how much money the pizza costs. So we're just going to do that. We're going to do $3.75 plus X is equal to $5.50. Hopefully you remember from yesterday, when solving equations, we do distributive property first. There isn't any in this problem. We look for collecting like terms. In the previous problem, where we had $2.50 plus X plus $1.25, we did have like terms. We combined those already for this one. And then if you have variables on both sides, you would move your variable to the left. We're not at that point no more, so we're going to do the inverse operations to solve this. So to get rid of positive 375, we're going to subtract 375 from both sides of the equation. And so we should end up with these canceling out. You're left with just X on this side, and it's going to be equal to $5.50 minus 375. And if you do that, you're going to get $1.75. And then that is your final answer. X is equal to $1.75. Again, if you're not sure how to do that, you can use the calculator. I really recommend Desmo's Scientific Calculator for 8th grade. Moving on to inequalities. You solve these just like we did it with the equations yesterday. There is one slight rule difference, and we'll talk about that when that happens on this paper. For number 36, we're going to rewrite it. Negative 19 minus n is less than 5, in parentheses, negative 8 plus 4n. And so the first thing you're going to do is simply do distributive property. 5 times this, 5 times that. So you're going to get negative 40 plus 20n is greater than negative n, and negative 19 just come down. The next thing that I want to do is see if there's any like terms on either side of the inequality sign. There are not, so we're going to skip that step. There are variables on both sides, so I like to move my variable to less, so I'm going to subtract 20n from both sides. And so that's going to leave me with negative 19 minus negative n minus 20n is negative 21n. Remember, there's always a 1 right there. And so the less than sign stays the same. Minus 40 comes down. These actually cancel out. So now we're to the point where we can start solving. To get rid of negative 19, I'm going to add 19 to both sides. And so negative 21 comes down and is less than negative 40 plus 19. Oddly enough, because the signs are different, you're going to subtract and keep the sign of the larger number. So 40 minus 19 is 21, and because 40 is bigger, it stays negative. The last and final step is to divide by negative 21 so we can get n by itself. And we're going to slide over here. So what's going to happen is these are going to cancel out just like they did before. You're going to be left with n. And then here is the rule that is different for inequalities versus equations. If you multiply or divide by a negative, you have to flip the sign. And we'll take a look at why here in a second. But negative 21 divided by negative 21 is positive 1. So n is greater than 1. So when you map that out on your number line, you're going to go to 1 and you're going to put an open circle. And then you're going to shade everything that is true about that. So everything that's greater than 1 is this way. So we're going to shade this way. And then we put a little arrow on it so that we know that it's everything that's greater than that. But here's why you have to flip the negative sign or flip the inequality sign when you're dealing with negatives. Think about this statement. 1 is less than 2. But if I multiply both sides by negative 2, I'm going to get negative 2 times 1 is negative 2. Negative 2 times positive 2 is negative 4. And based on our own number line that we can create, we can see that negative 2 is actually greater than negative 4. And so if you think about this, if this is negative 4, negative 3, and this would be negative 2, the greater side is always to the right. So that's why we have to flip the sign when we multiply or divide by a negative. All right, looking at number 37, I'm going to rewrite it so we have room to show our work. We have 26 minus r is less than or equal to negative 3r minus 3r minus 7. Okay, so the first thing I'm going to do is put my parentheses in because I forgot those, is do 3 times r and 3 times 7. So I'm going to get, and make sure that you do negative 3. So negative 3 times r is negative 3r. Negative 3 times negative 7 is positive 21. Negative 3r comes down. So does the inequality sign. Minus r, and 26 comes straight down as well. The next thing I'm going to do is I'm going to combine the like terms, negative 3r and negative 3r. Remember, combining means to add, so negative 3r plus negative 3r is negative 6r, plus 21 comes down. The inequality sign comes down as well. 26 minus r also comes down. The next thing I'm going to do is I'm going to add 6r to both sides so I can get move my variable to the left. And so 26 just drops straight down. Negative r, remember there's actually a 1 there, so it's negative 1r, plus 6r is going to be positive 5r. When this happens, you need to put a plus sign in between there. The inequality sign drops down, these cancel out, and then 21 just drops straight down. The next thing I'm going to do is subtract 26 from both sides. And I'm going to get 5r is less than or equal to negative 5. The last step is divide by 5. This is really important. This time, the sign stays the same, negative 1. we are actually dividing by a positive 5. Sometimes we get confused, and because this up here is negative, people want to flip the sign. Don't fall into that trap. You're dividing by a positive number, so you keep the sign the same. So r is less than or equal to -1. And you'll notice on our last one, it was n was greater than 1. We had an open circle. Because we have the equals to as well, we're going to go to -1, and we're going to have a closed circle this time. We want to fill that circle in because that indicates that -1 is included. And it's less than, so this time we're going to go to the left. All right. Moving on to number 38. Rewrite it again. 8 minus 3x. It's a terrible looking 3, so let's rewrite that. 8 minus 3x is greater than 6 parentheses x minus 4 close parentheses minus x. Again, we're going to do distributive property first. 6 times x is 6x. 6 times -4 is -24. Everything else is just going to drop down exactly how it was. We're then going to combine like terms. So in this case, 6x and -x. So combining, we add. So 6x plus -x is going to be 5x. Minus 24 drops down. 3x and 8 drops down as well. I'm going to move my variable to the left now. I'm going to subtract 5 from both sides, 5x from both sides. And I'm going to get 8 drops down. -3 minus 5x is going to be -8x. The sign stays the same. These cancel out. Minus 24 drops down. And then I want to start solving it, so I'm going to subtract 8 because it's a positive 8. If I subtract 8 from both sides, I'm going to get -8x left here because these cancel out. The greater than sign drops down. And then -24 minus 8 is -32. Again, if you're not sure how to do that, you can use a calculator. Last and final step is divide both sides by -8. And these cancel out. You're left with x is less than, because we got to flip the sign because we're dividing by a negative. A negative divided by a negative is positive. 32 divided by 8 is 4. So x is less than 4. So we're going to go to 4. We're going to have an open circle because it doesn't include the equal sign. And we said x was less than 4. So we want to shade this side of our number line. All right, moving on to number 39. Rewrite the problem. 7 parentheses -2 m plus 5 close parentheses less than -7m minus 14. So 7 times -2 is -14. M comes with it. 7 times 5 is 35. Less than sign stays the same. -7m minus 14 just drops down. And so this time, I'm going to move my variable to the left again. I'm going to add 7m to get rid of -7m. And so I end up with -14 plus 7, which is going to be -7m plus 35. The less than sign comes down. These cancel out again. -14 drops down. I'm going to subtract 35 from both sides of the problem so that I can get -7m by itself. Less than sign comes down. -14 minus 35 is going to be -49. And then the last and final step is divide by -7. Divide by -7. These cancel out. You're left with m. I'm dividing by a negative, so my sign has to flip. Negative divided by a negative is positive. 49 divided by 7 is 7. So m is greater than 7. So I go back to my number line, open circle, and fill in everything to the right of 7 because it's greater than. All right, moving on to these. These types of problems are determined if something is a function based on a graph. There's one really simple, easy solution. You're going to do what's called a line test. And so what you're going to do is you're going to take some type of straight line. I like to use a pencil when I'm working on a test. So, and you're going to run it. As soon as you see that it touches in two different places with that vertical line test, that automatically means that this is not a function. However, well, hold on. We have another vertical line test. We run it across the graph. Oh, it touches twice there and there. That means this is not a function as well. Not a function. So moving on to problem number 42. We're going to run our vertical line test again. And so this time we're running it across our graph. And I can't see anywhere where it touches twice. We'll zoom up so we can see the whole graph at the same time. It doesn't look really obvious where it touches exactly twice at the same time. So in this case, because it does not happen, that means that this is a function. Looking at number 43, run my vertical line test again, and it only touches once. So that means that this is a function. So looking ahead, that completes day 4's iLearn review. Looking ahead, however, looks like we're going to be finding slope. Slope from an equation, slope from given 2 points, slope from a graph. And we may possibly move into graphing a line from slope-intercept form. If we get that far, we get there. But for right now, we are going to definitely take a look at how to find slope from an equation, how to find slope from 2 points, and how to find slope from a graph. Again, that will be next time on day 5 of iLearn.